In this video, we're going to talk about right triangle trigonometry. So as you can see, we're given this triangle. It is a right triangle, and we have this angle theta. We can see there's some relationships with theta in regards to the three sides. So the side across from theta is the opposite side. The side right next to our theta, right here, is our adjacent side, and the side on the other side is the hypotenuse, and the hypotenuse is the side that is directly across from the right angle. So we can find 6 different trigonometric relationships. The sine of theta is equal to the opposite side over the hypotenuse. The cosine of theta is equal to the adjacent side over the hypotenuse, and the tangent of theta is equal to the opposite over the adjacent side. The cosecant of theta is equal to the hypotenuse over the opposite. The secant of theta is equal to the hypotenuse over adjacent, and the cotangent of theta is equal to adjacent over opposite. And as you can see, there's a relationship here that these are just flipped. So the sine of theta is opposite over hypotenuse, but the cosecant of theta is hypotenuse over opposite, so they have just flipped. Let's do an example. This word problem tells us that a ground crew worker who is 6 feet tall is directing a plane on a runway. If the worker sights the plane at an angle of elevation of 32 degrees when the plane is 150 feet in the air, what is the horizontal distance from the worker to the plane? So let's first draw a picture. So this box will represent our plane, and here's our man who is 6 feet tall directing our plane. And we know that he sees an elevation of 32 degrees. So this means from his line of sight to the plane in relationship to his line of sight to the horizon, which forms a right angle, right here is 32 degrees. So we've formed our right triangle. Now he's standing on the ground, and we know the distance from the plane to the ground is 150 feet. So we need to figure out this distance here. And we can see that it will be our 150 minus the 6 feet of our man, which is equal to 144 feet. So if we kind of pull our triangle out of our picture, we have our 32 degrees here and our 144 here. And as we can see from the original picture, we are looking for this distance here, x, because we're looking for the distance between the man and the plane horizontally, which is our x-axis direction, if we were to draw a little coordinate plane right here. So let's evaluate what sides we are given. We can see that we have the side opposite, so this is our opposite, and this side right next to that is not across from the 90-degree angle, so we have our adjacent. So looking at our trigonometric identities, we're going to use tangent of theta is equal to the opposite over the adjacent. That means our tangent of our 32-degree angle, because that's our theta, that's what the angle we're given, is equal to 144 over x. So to solve for x, you would multiply both sides by x and then divide by the tangent of 32 degrees. So you have x is equal to 144 divided by the tangent of 32 degrees. So now to solve for x, you can use your calculator and make sure your calculator is in degrees and not radians, and you'll get x is approximately 230.4 feet. So that is the distance between the worker and the plane in the horizontal distance.